Hello, class. This is my response to this week's discussion post, the first discussion post. Due to my surgery, I'm still having a hard time typing, so I figured the video would suffice, at least for right now. I'll probably be in this thing for another week or 2 weeks, so I figured this is the best way for me to still contribute to the class. This week we're talking about statistical power, and this discussion post wants us to explain the components of statistical power and determine which component is the easiest to modify and which one is the hardest to modify. I would start this off by saying statistical power within a study is the ability for the study to accurately predict what the probability is of rejecting the null hypothesis when it is indeed false. And so the greater the power, the more accurate you'll be able to determine whether or not it is valid to reject the null hypothesis if it is false. Within power study in statistics, there are really four main components. There's the alpha level, the beta level, the effect size, which can be bifurcated into the differences between groups and the variability of measures, and lastly, sample size. I will, for the first two, alpha level and beta level, they kind of go hand in hand. They're similar, but they're not the same at all. The alpha level is really how much type 1 error will you allow within the study. And with an alpha level, what that ultimately means is when you reject the null hypothesis when it is indeed true, and the beta level is accepting the null hypothesis when it's false. And a type 1 error, or an alpha, is usually chosen by the investigator, but it's usually set around 0.05. And this is the most concerning error. You try to reduce this error as often as possible. It's not as the beta level is not as it's not as important, but it's not as important as the alpha level. And to kind of conceptualize this, if we're working on a study and our null hypothesis is, and we're examining two different drugs, and our null hypothesis would state that there is no difference between the drugs at all. And our alternative hypothesis would be that there is a difference between the drugs. If we were to make a type 1 error, we would we would reject the null hypothesis. We would reject saying that there is no effect when we will we would reject that, say that reject the hypothesis that there's no effect, and therefore assume that there is an effect. However, let's imagine in this situation that the null hypothesis is true and there is no effect between these drugs. By making this error, we could, the investigators in this situation could prescribe or state that the alternative drug is better when there's really no evidence to support that. And that could potentially put subjects who take this drug in harm. And that's why we want to try and reduce this as much as possible. On the opposite end of the spectrum, with the beta level, we accept the null hypothesis when it's actually false. And so what that means in the same scenario is we are accepting the fact that there is no difference between these two drugs, when in fact there is. So we would stick with the standard of care that we're already using and not use this new drug. By sticking with the standard of care, we're not putting our subjects at increased risk. So while we're not hitting the mark that we were hoping to hit with this new treatment or new drug, we're not causing any more damage. With an alpha level, there's a possibility that we could cause more damage. So it's a little bit more concerning, and we need to pay a little closer attention to the alpha level as opposed to the beta level. With effect size, that's really measuring how big of an effect there is between these two drugs. And lastly, the sample size, which is how many people you need in the study to get the kind of power that you want. And in my opinion, I would say that the easiest to manipulate would be sample size, but that there needs to be a caveat with that. Let's take, for example, that we're measuring these two variables, and the effect size is very, very small. And so in order to magnify that to see what the actual effect is, we would need to increase the power of the study by having more subjects in the study, increasing the sample size. Now, if the effect is very, very small, we would need thousands of subjects just to be able to notice that. If we have enrolled that many subjects, there are some issues with that. the resource depletion because it would cost a lot of time, effort, and energy to enroll and follow thousands upon thousands of subjects. Additionally, by enrolling a large amount of subjects, we run the risk of putting a large group of people at increased risk because this is an investigational product. There's always going to be risk involved. So we have to do a cost benefit analysis and weigh the risks and benefits of increasing the sample size to that level, especially if there's really just a small effect size. But I will say that it is probably the easiest to manipulate because you can always increase or decrease the amount of subjects you want in a study. You really just need to, like I said before, do a cost benefit analysis to determine what your cutoff point is. And once you reach that cutoff point, it's not even really worth it. I would say the hardest to manipulate would be effect size because there may not be an effect, a noticeable effect, or a significant effect between two variables because there could be, competing factors, there could be confounding, there could be a lot of different other aspects that could affect the effect size, or it just may not be there. And we could be spending time, energy, effort, resources to detect an effect that is so small, so minuscule that it's not even worth it in the long run. And ultimately, the effect size is going to come down to the variables being measured, and that's kind of outside of our purview. We the alpha level is often chosen by the investigator. The beta level is often chosen, how we want to how much type 2 error we want. It's something we select. And the sample size is also something we select because we choose who is enrolled in the study and who isn't. So we have a lot of control over those three aspects. The effect size is really dependent on the variables that are being used, and it's kind of out of our control. Now we can use statistical methods to work with that, but ultimately we have little control over that aspect. Those are my thoughts on this week's discussion. If anybody has anything they can add to this, or maybe enlighten me in some of these things, I would really appreciate it. I look forward to hearing from every one of you, and thank you for taking the time to watch this video.